All right. Do you hear me? Do you hear me only from my voice or from some speaker somewhere? Speaker somewhere. Okay, it's good. All right. So good afternoon, everybody. My name is Robert Bissonnette. I'm a dermatologist from Montreal, Canada. I'm the current IEC president. Welcome to this IEC symposium. If I can have the next slide, it's interesting. That's the first time I see this. There are two big squares. One is next and one is previous, so very easy. But the next one doesn't work. Nothing happens. So we have a very nice, very interesting symposium today. It's a very busy one. We have numerous speakers. So it will be very important for all speakers to be on time if we want to finish on time. Good, great, all right. So QR code. So for those of you who attended IEC symposia in the past, this is a first. We're going green. So in the past, we were used to give big booklets with bios of every speaker and a summary of the different presentations. Now this is all available online. We saw that many people were taking photos of the paper that we were giving with their phones. So now you can do this with the QR code. Please have a look because you have more information on each of the speakers today. So the title, the subject of the symposium today is Pathophysiological Insights into Atopic Dermatitis and New Therapeutics Developments. Few housekeeping comments. In fact, the main one is just to inform you that this session is being recorded. It is something we always do at IEC. As all of you know, it's not very easy for people from North America or South America to travel to Japan, and it's not very easy for people from Asia to travel to North America. So many, many people view these recordings online, so everything is recorded. This I've already spoken about. So for those of you who might be less familiar with IEC, IEC is a non-for-profit organization that exists since 2014. It was founded by Dr. Emma Guttman, who will be giving a talk today, and Dr. Amy Powler. It is led by dermatologists and allergists who have a strong interest in atopic dermatitis. We currently have 124 experts from 28 countries around the globe. So what you see on this map on the right side, every country that is orange is a country where IEC has at least one counselor or associate. The countries that are in gray are countries where we don't. We are always open to have new counselors and associates, specifically if you are from Asia, Asia Pacific. We are welcoming new counselors. So if you have a strong interest in AD, if you do research in atopic dermatitis, you publish in atopic dermatitis, you teach, or a large portion of your practice is on AD, I would suggest having a look at our website, look at the criteria, and if you want to join, we're open to receive your inquiries. So IEC's mission. So our mission is focused on two major aspects. One is research and the other one is education. We want to facilitate atopic dermatitis research and we want to disseminate evidence-based information about atopic dermatitis. All this to promote good practices in the care of patients with atopic dermatitis worldwide. We'd like to collaborate with other organizations, other stakeholders, patient organization, pharma companies, other non-for-profit organizations to make this a reality. How do we do this? So what do we do at IEC? We do two main things. The first is educate with symposia, like the one we're having today. So we're having on a regular basis symposia at major dermatology meetings, international meetings, and sometimes more regional meetings. We also want to favor research. What we do is we publish in high-impact journals, we publish systematic literature reviews, we publish consensus papers, opinions from IEC. We are also involved in research through funding international fellows, and we'll talk about this. I'll talk about this in a few minutes. So in order to be able to do this, we obviously need funding, and I want to thank all the companies that are currently making donations to IEC, and this is a list of all the pharma and biotech companies that are contributing to IEC. If you work for a pharma or a biotech company and your name is not on the list, if you're in the room, you should get there. Yeah. Dr. Guttman is right. So if you're in the room, it means that you have an interest in atopic dermatitis. So please come and talk to either myself or our CEO, Alan Stein. So our activities, we've been very active this year. This is one of our busiest years. We were at the American Quad-AI meeting in February. This is the American Allergy Association meeting. We were at AAD with an interesting session on prurigo nodularis. We're today at ISID. We will be at RADLA in a few weeks. And the RADLA is a meeting of South American dermatologists. We will be at the World Congress of Dermatology in June. Non-atopic challenges in AD patients, contact allergy, bone fractures, CV risk, mental health issues. Some of these things we don't talk too much about or too often about in atopic dermatitis. EADV pruritus, the main symptom of patients suffering from atopic dermatitis. So we'll be in Berlin. We'll also be in Vienna at ISDS for basic research techniques in atopic dermatitis. IEC fellowships. So what you see on this slide is a list of fellows that IEC funded in 2021 and 2022. We currently have one open program. So if you have, these programs are targeted towards residents who are completing their dermatology training. So these programs are for dermatologists, recent graduates, could be a few years from completing residency, could be somebody who is completing this year and will be interested to do a fellowship. We have one program that is open. It's a one-year research fellowship in atopic dermatitis with one of our Canadian counselors or associates, and that would include Dr. Jack that you will hear today. We will also be soon announcing a program for 2024, which will be an international program. So both clinical fellowships, which are shorter fellowships of 1 month, and a long research fellowship. So if in your environments, if people you know, in your academic institutions, you have residents that are interested in atopic dermatitis and would like to do a one-year fellowship, this is something that is possible through IEC. Manuscript. So if you're an IEC counselor or an associate, if you have an idea for a manuscript, please get in touch with Alan Style or myself to discuss. Any questions about IEC? This is our CEO's information, contact information. Now, today, our agenda today, and I just realized that I forgot my sheets to introduce the speaker. So give me 10 seconds. Good. So it's we have 3 co-chairs. It's a lot of co-chairs, but these people are all very interesting and all very different. So, and I'll go in the reverse order to introduce them. I'll start with Carolyn Jack. So I've known Dr. Jack for many years. We collaborated together when she was a resident at McGill. She's currently an assistant professor at McGill University in Montreal. She's a scientist at the Infectious Disease and Immunity and Global Health Program for the Research Institute at McGill. She founded the McGill Center of Excellence for Atopic Dermatitis, the first tertiary care center in Canada dedicated to adult atopic dermatitis. Her research interests include immunophenotyping of type 2 immune responses and the role of S. aureus strains in atopic dermatitis. Our second co-chair is Dr. Emma Guttman. Yoshiki, everybody knows Emma. She's one of the founders of IEC. one of the most well-known researcher in atopic dermatitis. She's currently System Chair of the Department of Dermatology at the Allman Professor of Dermatology and Immunology at the Icahn School of Medicine at Mount Sinai, New York. She is Director of the Center of Excellence in Eczema and the Laboratory for Inflammatory Skin Disease. She co-founded IEC, as I mentioned in the past, and her current research interests are obviously atopic dermatitis and alopecia areata. And last but not least, the current ISID president. We are fortunate to have Kenji Kabashima today, who is professor and chair at the Department of Dermatology at Kyoto University Graduate School of Medicine and a principal investigator at the A-Star Research Skin Labs and Singapore Immunology Network. So I was talking to Kenji just before the session today, and I asked him, do you really do research in both Japan and Singapore? Do you really travel? Knowing Kenji, I was not surprised, because I know he runs so much that he can do anything, but he does. So he has 2 labs in 2 different countries. And his main research interests include the mechanism of inflammatory skin diseases in humans and mice, and 3D visualization of the skin using 2-photon microscopy. So just briefly, we are already a few minutes late, so I'll go quick on the program because you'll be able to read everything. Just want you to know that we will have a break at 1:30, and that the program will end at 3 p.m. this afternoon. So I would like to invite Dr. Kabashima to say a few words.
Thank you, Robert. I'm co-chair of this session, and thank you very much for coming all the way to Tokyo. I'm glad to see all of you, and now atopic dermatitis eczema is a very hot topic. So please enjoy this meeting and also the rest of ISID meeting. Thank you very much.
Hi everyone, how exciting to be here in person after so many years. And I'm truly excited to introduce the next speaker, Dr. Yoshiki Tokura, that is known to all of us and definitely very known in Japan and very known for atopic dermatitis as well. He will talk about endotypes of atopic dermatitis. But before his talk, I think it's hard to introduce him because he did so many things and he's so known to all of us. He's the director of the Allergic Disease Research Center in Kakegawa, Japan. I hope I pronounced it well. And these areas of interest center around the immunology and allergology, as well as cutaneous lymphomas and photobiology. He served as the leader of many societies, including as the president of the Japanese Society for Investigative Dermatology, president of the Japanese Society for Cutaneous Immunology and Allergy, and the vice president for the Japanese Dermatological Association. He also served as the Secretary General for the International Investigative Dermatology, IID, that was in 2008 in Kyoto. That was my first time in Japan, so I remember that meeting very well. And in addition to his extensive authorship, he served as editor-in-chief for the Journal of Dermatological Science and for the Journal of Dermatology until 2013. So we are super excited to have you here and talk to us about endotypes of atopic dermatitis, a field that is really expanding in recent years.
Thank you very much for Professor Guttman for introducing me. First of all, I'd like to express my sincere gratitude to the organizing committee of IEC for giving me this opportunity to talk on the atopic dermatitis. It's a great honor for me to be here. Can I have the next slide? yeah, this is a COI. And 15 years ago, I was the Secretary General of IID 2008 held in Kyoto. And then at that time, we had several committees for the establishment of IID 2008. And then this was the one of them. And then so this meeting, ISID, is very nostalgic to me. And then 15 years ago, the submitted abstract was 900 in number, but this time more than twice. So this meeting is expanded, the remodeled. So congratulations, Kenji Kabashima, for this very nice meeting. So current issue, one of the current issues of atopic dermatitis is to categorize atopic dermatitis into subtypes. Because subtyping is important for precision medical approach to establish a personalized therapeutic approach to AD. And the subtyping is traditionally or historically performed by the phenotype, but the endotype, currently endotypes as well as phenotypes are required for characterization of individual patients. But I think to better understand the subtypes, attempts to adjust each classical subtype to endotype are necessary. So this is a methodology of subtyping of atopic dermatitis. So we have, of course, phenotypes. This is a historical one, and the clinical features, and the endotypes. Currently, endotypes have been paid attention to, and this represents the pathogenic mechanisms with multiple viewpoints. So viewpoints include the skin barrier impairment, and then the immunological state, and the protein properties, protein antigen properties, and the metal hapten antigen properties. So this is a phenotype of atopic dermatitis, highly frequently seen in our daily clinic. And then you see these clinical features, and then it's somehow difficult to categorize atopic dermatitis into subtypes by using these manifestations, because almost all skin manifestations belong to the common extrinsic atopic dermatitis. One exceptional sign is Denny-Morgan folds. This was reported to belong to the intrinsic atopic dermatitis, according to the Dutch group study. On the other hand, patients sometimes show the palmar hyperlinearity and the plantar hyperlinearity, and ichthyosis vulgaris. These phenotypes also closely linked to the genotype or endotype, because filaggrin gene mutations are seen in these patients. This is a phenotype less frequently seen at the clinic, lichen amyloidosis and the vitiligo, and the chondrodermatitis of the auricle, and the angiohistiocytoid papules. They are prominent features. And we, even these prominent features, we cannot distinguish subtypes by using these phenotypes, because these phenotypes also are seen in the common extrinsic atopic dermatitis. So phenotype has a limitation for the subtyping atopic dermatitis. This is a diagnostic standard of atopic dermatitis by Hanifin and Laika, a very famous one. And if you look at these standards, I just highlight the phenotype in blue and the endotype in red. As you can see here, ichthyosis, palmar hyperlinearity, these are phenotypes, and the immediate type 1 skin test reaction, and the elevated serum Ig, these are phenotypes. endotypes. So this diagnostic standard is a mixture of phenotype and endotype. These are classical, representative classical subtypes of atopic dermatitis. You see extrinsic and intrinsic types, and the European American and Asian types, pediatric and adult types. These are based on the serum IgE levels and ethnicity and age bracket. For endotype approach, the question is that how do these classical subtypes correspond to endotypes? Or alternatively, endotypes may not be necessarily relevant to classical subtypes. I just mentioned the extrinsic and intrinsic atopic dermatitis because this is a representative subtyping of atopic dermatitis. And also you can see the historical nomenclature for extrinsic and intrinsic atopic dermatitis: mixed, pure, allergic, non-allergic, classical, and atopiform dermatitis. And the frequencies of extrinsic and intrinsic atopic dermatitis is largely 8% versus 20% in many countries. And also female predominance is seen in intrinsic atopic dermatitis. So here you have the extrinsic atopic dermatitis. The patients have barrier impairment and high IgE levels. And some of the patients show the filaggrin gene mutations. And they show the ichthyosis vulgaris and the palmar and the plantar hyperlinearity. On the other hand, intrinsic atopic dermatitis, barrier relatively preserved, and they have the normal IgE level. And some of the patients, just like 70% of patients, intrinsic atopic dermatitis patients, show the metal allergy because 70% of patients have positive patch test to at least one of the nickel, cobalt, and the chromium. So extrinsic atopic dermatitis, protein antigens penetrate through the impaired barrier and leading to the type 2 responses. And the intrinsic atopic dermatitis, non-protein antigens, metals, haptens, come through the relatively preserved barrier and then induces not only type 2, but also type 1 responses and also Th17, Th22 responses. This is circulating T cell populations in atopic dermatitis. We can see the extrinsic and intrinsic atopic dermatitis, they have the high frequencies of Th2 cells. But the extrinsic atopic dermatitis, the frequency is higher than intrinsic atopic dermatitis. Intrinsic atopic dermatitis is characterized by high frequency of Th1 cells, interferon gamma positive T cells, and also tended to show the Th17 high characteristic. We have studied the mechanism of intrinsic atopic dermatitis. We focused on the suprabasin deficiency, maybe one of the causes of intrinsic atopic dermatitis. But I have no sufficient time to show this, so I just show the suprabasin deficiency. We are focused on the deficiency of suprabasin. I move on to the endotypes, the viewpoints. These are viewpoints and methods to classify atopic dermatitis, cytokines, allergens, epidermal barrier, and the intercellular lipid state, and the innate immunity. These are the viewpoints, and also the some studies show the methods for endotyping atopic dermatitis, serum biomarkers, as you can see here. Perhaps the most important viewpoints is cytokines. So cytokines, the endotypes includes the Th2 cytokine high, type 1 cytokine high, and or IL-22, IL-17 high, or mixed. there have been several reports that regarding the relationship between atopic dermatitis subtypes and cytokine phenotype endotypes. For example, in intrinsic and Asian types, coexistence of multiple cytokine axes of Th17, Th22, and Th1 was found. And another study showed that the intrinsic atopic dermatitis shows a similar Th2 and higher Th17 immune activation compared to extrinsic AD. And the Asian atopic dermatitis phenotype combines features of AD and psoriasis with increased Th17 polarization. These papers are from Emma Guttman's group. And pediatric and adult subtypes, CLA, positive Th1 cells were significantly lower in AD infants than older patients. And after infancy, CLA negative Th2 cells and IL-22 increased. So to me, the extrinsic and the European American and the pediatric types Th2 dominant types, and the intrinsic subtype and the Asian American, Asia subtype and other subtype have the additional Th1, Th17, Th22 skewing immunological conditions. So here you have the extrinsic atopic dermatitis. Th2 immunity is mainly involved in the pathogenesis. And the intrinsic atopic dermatitis, Th2 is also involved, but Th1 and the Th22, Th17 immunities participate in the pathogenesis. And the Asian AD, type 2 immunity, and also Th22, especially IL-22 is involved in the pathogenesis of this Asian type of atopic dermatitis. Sometimes we see the Asian type of atopic dermatitis, the phenotype is just like psoriasis. It resembles a psoriasis, so there is a well-marked eczema here. So other viewpoints includes allergens and the epidermal barrier and the intercellular lipid state, and allergens, protein allergens, and impaired epidermal barrier. These are closely associated with the extrinsic atopic dermatitis. And the metal antigen and the preserved barrier is linked to the intrinsic atopic dermatitis. Well, perhaps the innate immunity is also important for subtyping atopic dermatitis. But the data of innate immunity, are there any variations among the patients in terms of innate immunity? We don't know, not yet. But IL-20, IL-33, IL-25, and the TSLP, and innate lymphocyte type 2, or the study is ongoing. So in the future study, we can subtype, endotype the atopic dermatitis by using innate immunity. And finally, serum biomarkers. This Dutch group already reported 2 cohort studies. Later one is this one. And then they used the 143 biomarkers and then classified into 4 clusters. So cluster A is the skin-hovering chemokine IL-1 receptor 1 dominant. My impression is that this cluster A possibly represents AD with high levels of severity associated chemokines. And the cluster B is Th1, Th2, Th17 dominant. Perhaps this represents heavily inflammatory atopic dermatitis. And the cluster C, Th2, Th22, PARC dominant one, and may represent AD with chronic lesions or Asian type. And the cluster D, Th2 and the eosinophil inferior type. This is, I think this is represents the intrinsic atopic dermatitis. But endotyping using serum biomarkers may be fundamentally different from conventional subtyping, and it may be difficult to endotypes to comprehensively correspond to the classical subtype. So the authors say that the top 10 biomarkers include these 10 biomarkers. And surprisingly, none of those markers are Th2-related cytokines. There's Th2 cytokines, none in the top 10. So this is how we interpret this finding. It's somehow difficult. So to sum up my talk, AD is a heterogeneous condition. So subtyping AD is a crucial issue. And the classical subtypes of AD are represented by extrinsic, intrinsic, European, American, Asian, and adult and pediatric subtypes. The endotype as well as phenotype is required for characterization of individual patients. And for precision medical approach, such as therapeutic choice, endotypes of AD should be clarified. And the endotypes of AD can be stratified from different viewpoints, including cytokines and allergen and epidermal barrier, ceramide variation, and the innate immunity and the microbiome and the serum biomarkers. And the cytokine-based endotype is an important one, and categorized in type 2 cytokine, type 1 cytokine high, and L20 to L17 high, or mixed subtypes. Finally, biomarker-based endotypes are related to individualized treatment options. Its daily clinical use is a future issue. So thank you very much. I appreciate these collaborators for providing data. And thank you very much for your kind attention.
So I'm super happy to introduce the next speaker that is a very good personal friend of mine, Yosipovitch, that comes from Miami. He is known to all of us. And once upon a time, he told me that he works on itch because he has itch in his name. He's a tenured professor and the Stiefel and Dow Chair of Medical Dermatology at the Dr. Philip Frost Department of Dermatology in Miami. And also directs the Miami Itch Center that focuses on chronic itch as a disease state. And prior to joining the faculty of University of Miami, Dr. Yosipovitch was the founding chair of Temple University's Department of Dermatology and directed the first translational clinical and research center dedicated to the study of chronic itch in the United States. And I think he made a really seminal contribution to atopic dermatitis and the studies of itch and particularly neuroinflammatory circuits. And I cannot think of a better person to give this talk today. So Gil.
Well, thank you, Emma, for your kind introduction. It's a pleasure to be here. And thank you, Robert, and all the IEC. It's quite amazing that in less than 10 years, you're so big. I'll today discuss a bit the pathophysiology. Kenji, when I invited me, said that I don't need to talk just about atopic eczema because I think that it's important to understand a lot of the neuroinflammation beyond just atopic eczema. So we'll discuss a bit the pathophysiology of chronic itch, and in particular, we'll discuss how type 2 inflammation is associated with that. Then I'll a bit go into pain, and I'll tell you why, because I think that there's a lot of interactions there that we're now better understanding, and in particular in atopic eczema, our patients have also pain with their itch, and that comes to the area of neurosensitization. And then a bit about systemic itch, because my talk is about neuroinflammation. I'll present some new data and some targets for treatment. So when we talk about itch, we're talking basically about two types of itch. Acute itch we won't discuss today, And this is mainly mediated by the histaminergic nerve fibers. And then there's chronic itch, which actually the majority of it is non-histaminergic. We have C nerve fibers, and we have a lot of layers. There's a peripheral layer, and that would be the focus of my talk today. I'll discuss a bit about BNP. This will highlight today a bit. And I won't discuss my interest a bit in the spinal brain just because we have limited time. But again, I think the most important aspect here is the peripheral aspect of itch. And let's simplify that first by understanding that there are two major type of itch receptors in the skin, and they're in the keratinocyte, the G-coupled protein cell receptors, and TRP, transient receptor potential channels. And into that cocktail, there's a lot of cytokines. It's always more complex. There are many G-coupled protein cell receptors. There are also many TRP channels. But this comprehensive figure that demonstrate that always things are complex in dermatology. And I have to mention that, we talk a lot about T cells, but mast cells, T cells and mast cells, but also eosinophils, even neutrophils, and a lot of recent studies been done on basophils and macrophages. All of them are contributing to this itchy conditions that are complex. And in terms of understanding them, there's a lot of crosstalk between the neuroimmune factors. And basically, what it's important to understand is that the majority of actually itchy condition, the most itchy conditions, and I know Dr. Tokura kind of mentioned today that the biomarkers are not so type 2 inflammation in atopic eczema, but I'd like to go back and say that type 2 inflammation has a significant role in many types of chronic itch, not just in atopic eczema. So you all know about IL-4/13 and IL-31, the itchy cytokine, but they also interact with these TRP channels, in particular TRPA1, less with TRPV1 in terms of a chronicity, but they have also role. But what it's important to understand is also that the nerves themselves secrete neuropeptides that activate the immune cells. So by secreting substance P via activation of a receptor now that I'll discuss a bit later, MRGPRX2, they activate mast cells, they activate macrophages, basophils, and T cells to secrete also cytokines. So there's really a vicious circle in interactions between neuropeptides and neurogenic inflammation to itch. And it's important to understand that because I think that in the future we'll have to address these issues in terms of treatments. But I want to emphasize again the idea that it's not just atopic eczema and prurigo nodularis. I think all of you know that chronic urticaria has type 2 inflammation, but even diseases, and these are diseases that are extremely itchy. Scabies has type 2 predominance. This is work from Takashi Hashimoto, who was my former fellow, showing that stasis dermatitis, CTCL, and the list goes on, and even in chronic pruritus of unknown origin, and even in patients with chronic kidney disease, when they have itch, there's a predominance of type 2 inflammation. Don't misunderstand me. Psoriasis has, by the way, IL-31, which is an itchy cytokine correlating to itch. But there are type 1 and type 17 cells or immune reactions that cause itch. But if you look, the majority of itchy conditions are mediated by type 2 cytokines. And I mentioned IL-31 because I can't forget the important studies that Kenji did on IL-31. And I really believe that it's coined accurately the itchy cytokine because it has a direct effect also on nerves, and it occurs in many conditions. This is an example of a patient with chronic kidney disease with itch, and you could see here that in patients with a chronic end-stage renal failure that is extremely itchy, there is a significant increase in IL-31. And I'd like to mention another factor in the itch type 2 inflammation. This is a extracellular matrix protein, periostein. This is an interesting molecule because it's secreted by fibroblasts, and it increases, it's well known, and Emma published that too, that it's highly associated with atopic eczema. But what we didn't know is that it can activate directly nerves by its receptor integrin alpha beta that is on nerve fibers, inducing itch. So it has a double kind of effect of an itch scratch cycle, because the more you secrete a periostetin, it increases the secretion of IL-4 and 13. And recently in PN also, we've shown that in different diseases, including prurigo nodularis, bullous pemphigoid, stasis dermatitis, even in systemic sclerosis, scabies, the list goes on and on, but this is a very valid protein in terms of itchy conditions. This just shows, and this was nicely shown by my colleague, Dr. Mishra, and most of the work, again, is a Japanese former fellow of mine, Dr. Hashimoto, who published in humans, but during that period, a group in North Carolina led by Dr. Santosh Mishra showed that in animal models, you inject periostetin, it induces itch both in mice, dogs, and monkeys. And clearly, this is a molecule that you should be on alert to, because there are actually drugs that can target it. So this is kind of summarize the role of the type 2 inflammation in periostetin in this condition. And we've done an itch transcriptome at the time, looking at patients with atopic eczema and psoriasis. And again, in addition, we were fortunate to have a monkey colony. This is work that we've done in Wake Forest, where we had monkeys. They have a very large monkey colony of itchy monkeys. We followed them for 5 years and found out that these had no atopic eczema, but they didn't have really any inflammatory skin disease, but they were extremely itchy. And looking at the itch transcriptome of them and comparing it to patients with atopic eczema and psoriasis, so we found again that the itchy cytokine IL-31 is common denominator in all these conditions. Tryptase, which is the ligand for PAR2 receptor, which is a non-histaminergic pathway, very important in itch. MRGPRX2, a G-coupled protein receptor, substance P, mu opioids. As you know, mu opioids are inducing itch, and they have an anti-pain, and NK1 is the receptor for substance P and some of the kallikrines. But I want to emphasize a molecule that I think we'll hear about more and more in the next couple of years in terms of neuroinflammation, MRGPRX2. MRGPRX2 is overexpressed in mast cells in conditions like chronic urticaria, but as we've shown and other groups have verified, that is that MRGPRX2 highly correlates to itch and atopic eczema and other conditions, and clearly is again a target for new developments of drugs. It also induces neurogenic inflammation and also is involved in pain. And interestingly, in the same group of MRGPRs, there's an MRGPRX4. This is on nerve fibers, and we now know that this is the receptor for cholestatic itch, another horrible itch that occurs in patients with end-stage or cholestatic liver diseases. And I'd like today to point to a new kid in the block called BNP, brain natriuretic peptide. We've known that this is a neuropeptide that is involved in the periphery in mice models, but we didn't really know about its role in itch in patients or in conditions. And what we show today in, it's a concurrent session that our IFSI Society has now, but it's going to be in poster 561, is we've shown that my researcher, Dr. Nat Kemper, demonstrates nicely that BNP is highly elevated in different forms of chronic itch. The most high correlation is in patients with chronic pruritus of unknown origin, also in systemic itch. And what was interesting that led us to work with Dr. Mishra's group, injecting BNP and showing that it does a dose-dependent expression of itch. And interestingly, by blocking in the periphery, by the way, BNP is highly also correlating to atopic eczema itch, but by blocking the peripheral aspect in the skin, we're able to actually induce still scratching. So I think that this is one of the new findings for our group, is to see that overall this is a marker for chronic itch of different types. Interestingly, in neuropathic types of itch, it doesn't show any correlation. And now I'm going a bit into the itch and pain arena, because there's a lot of pain involved in the itch. And I'm giving an example of atopic, psoriasis, prurigo nodularis, also hand dermatitis irritant. And there's a lot of interactions here because the neural system is very similar in terms of a lot of these receptors. And basically, what is important to understand that there's a lot of overlap. So, but there are some differences. Again, MRGPRs are both involved in these conditions. TRP channels are very highly involved. Substance P, P2X is also sometimes a receptor that you could see in patients with chronic itch. But I'd like to mention that there are some also distinct differences. And the distinct differences can enable us to better understand sometimes treatments for these patients, because basically, if a patient has a lot more pain, most of the cytokines that are involved in pain conditions are more type 1 and type 3, IL-17A. There are some TRP channels like TRNP2 and TRNP3 that do not show up. So far, we didn't see them in itch. Periostetin we do not see associated with pain. And kappa opioids are overexpressed in patients with itch, pain. Kappa opioid receptors are downregulated. This is beautiful studies that my Japanese fellows, Dr. Takamori did. And basically, you don't see that in pain. So there are some similarities, but there are also differences. But I mention again these TRP channels because some of them are very unique to the skin, and in particularly TRPV3. This is a ion channel highly associated with epidermal conditions, and you could see in the poster, I think 651, if I'm correct, we are completing a study on TRPV3 role in itch, in lichen simplex chronicus, blocking it, so we'll have these results soon. But it's an exciting area. So going into other areas of itch is understanding neural sensitization, meaning that the neural system is overactivated in patients with chronic itch. This is very common in conditions like atopic eczema. And this figure, again, this is a beautiful figure that actually Dr. Takashi Hashimoto did by himself, demonstrating how the neural sensitization phenomena occurs in different layers of the skin, plus the spinal cord and in the brain. But it's important to understand that really it's something that all the patients with chronic atopic eczema suffer from. So that's why when they put a sweater on their body or there are changes in temperature, they feel itch, or someone touches them or doing a massage on them and they feel more itchy. And another example of this condition is in prurigo nodularis. But it's interesting that we've looked at, this is databases of inpatient hospitalization and looking at patients with PN. Apparently, patients with prurigo nodularis, which is known to be a neural sensitization phenomena, highly correlate with 3 different other neural sensitization phenomena that are painful. In particular, look at the high correlation with interstitial cystitis, also with fibromyalgia and irritable bowel syndrome, suggesting maybe that there is a common denominator here. And as you know, there is also significant involvement of type 2 inflammation in PN. And again, this shows in the studies that Takashi showed very nice correlation between the periostetin with itch intensity in prurigo nodularis. This was confirmed recently by work with Dr. Quatra's group. Summarizing a bit, another area is skin microbiome, hot topic, and just to better understand it, we all know that in atopic eczema there is lack of diversity, but and we know that Staph aureus can activate type 2 inflammation, and again, maybe aggravating the itch. But we looked at prurigo nodularis and lichen simplex chronicus. These are patients that are not with atopic eczema, and I was fortunate enough to have a fellow from Korea, Dr. Hazel Kim, Professor Hazel Kim, who performed these studies both in Miami and in Korea, and we found, and it's not so easy to do in two populations, and the similarity is so significant between the two, showing that there is a predominance of Staph aureus, lack of diversity in prurigo nodularis, also in lichen simplex chronicus, and there's a significant increase in staph protease, serine protease, but only in the Korean population was highly correlated to itch. So again, understanding more mechanistically how the microbiome can activate the type 2 inflammation and itch is an area of interest. So summarizing my talk is how we can treat the itch. So, I don't want you to get the message that we'll just treat type 2 inflammation and we'll solve all the itch, but clearly this is why most of these drugs that target the type 2 inflammation can reduce itch. And Dupilumab, you all know in atopic eczema, and just last week, the pivotal trial of Dupilumab effect on prurigo nodularis was published. The 2' studies showed similar results, significant antipruritic effect. So it doesn't surprise you after I gave you kind of a prep talk how significant type 2 inflammation is. And clearly also nemolizumab, and this was presented just 2 months ago by my colleague Dr. Quatra, on nemolizumab, improved significantly itch and skin lesions at week 16. Again, very robust effect of these drugs on itch. Just to let you know, if I would give you a talk 10 years ago, this list of drug trials in itch was maybe 5 or 6 drug trials, but now we have 532 studies targeting itch related to different diseases. So it's quite amazing how this field had exponentially grown. And just yesterday, we published in JAD just emerging treatment for AD itch. You could see here there are more than 10 different, I think 15 drugs, all studied now targeting mainly the type 2 inflammation, but also targeting OX40 that has a significant antipruritic effect, targeting some of the neuropeptides, the TRPV1 channel. I won't be surprised there is a TRPA1 that was not mentioned. And again, clearly the IL-4, IL-13 and IL-31, and also even drugs that don't work through directly through cytokine, but new phosphodiesterase inhibitors, and also the AHR, these are work that Dr. Robert Bissonnette had done and shown antipruritic effects. So stay tuned that the field of anti-itch is so actively advancing. So to conclude, I would say that chronic inflammatory itch is mediated by non-histaminergic pathway. There's a significant crosstalk in immune and neural system with multiple receptor, and clearly there's a new antipruritic era of drugs targeting specific receptors and type 2 cytokines. I didn't even mention the JAK-STAT. They're very effective in treatment, but they're not so specific, but clearly they have a significant effect. And I want a kind of message is that I don't think we solved all the problems of itch, and there won't be one drug for all types of itch, so we have a lot more to work on. And I'd like to acknowledge a lot of the folks that worked with me, and particularly Nat Kemper, who directs my lab, and some of my researchers, a lot of medical students, and many international fellows, many from Japan, that I'm very proud that they have advanced the field and continue to do that. many collaborators outside from different places. And I'd like to invite all of you also to the World Conference of Itch that we'll have in Miami in November 5th to 7th. So I thank you again.
Thank you so much, Gil, for this really brilliant talk. So I'm very excited to invite Caroline Jack, that is also one of the co-chairs here, and a rising star in atopic dermatitis, to give this talk. She will give one of the shorter talks that we selected for presentation on high-dimensional analysis, identifies variably persistent activated skin homing Th2, TC2 populations in atopic dermatitis patients on Dupilumab. Caroline Jack is an assistant professor. Robert actually introduced her at McGill University. She just received a big research grant, so congratulations. And we are super excited to have her talk here.
Thank you so much. It's a real honor to be here, and I'm very pleased to be able to present to you this data. So I'm based in Montreal, and we're situated up against this nice mountain. And as you see here in the background, we once had a university hospital really nestled in the mountains, and now it's been dismantled along with our research institutions into this giant complex in order to perform translational medicine. So this is where I sit now. These are my disclosures. So as an immunologist and dermatologist, I am essentially a doctor of last resort for a large number of patients in this province, where patients come from all the way up north in the Inuit communities or First Nations. We have a large variety of patients, multi-ethnic populations, and like you, I've been following very carefully and with a lot of interest the development of these targeted therapies in disease. I have a special interest in IL-13, and in particular, learning about these populations of pathogenic effectors. We've learned and known for a long time from Dr. Guttman about the importance of these IL-13 producing cell populations, showing that the skin homing T cells expressing the cytokine do correlate with disease. And we've been following recent publications by Dr. Brunner's group as well, looking at how this cytokine, in fact, does persist following treatment in clinically resolved skin. And we're particularly interested in these populations that he's described with this label called CRTH2, describing a population of pathogenic effectors. So we've learned that Th2 cells are not all the same, and there's a subpopulation of effectors that is labeled by the CRTH2 receptor, which binds prostaglandin D2, and is characterized by the expression of IL-5 and IL-13, notably not as high IL-4, and these cells are really licensed to ill by expressing these alarmin receptors, so allowing them to respond very directly to the skin, obviating the need to be primed in the lymph nodes. So we've shown in our lab that, in fact, this pathogenic effector Th2A-like functional response of high IL-13, IL-5, IL-9 is relatively easy to generate in vitro from healthy PBMCs with a little bit of TSLP and Staph aureus enterotoxin. We still don't know whether or not these cells are really true blue Th2A, CRTH2 expressing cells. And we've found in the literature recently, by looking at what's been published, quite a lot of conflicting data on CRTH2 expressing cells. So looking at a recent publication by Van Wyck's group, finding very low levels of CRTH2 expressing cells in the blood, in contrast to a nice Japanese publication showing high levels of CRTH2 cells in atopic dermatitis patients, and those actually correlating with IL-13. So we really asked ourselves, what is the role of these cells? And we think that the IL-13 pathogenic effectors with this marker actually may play a key role in the pathobiology. And so we wanted to test the expression of CRTH2 in some pilot studies using the available banked blood that we have, and to compare compare hypothesis-driven versus a high-dimensional analysis of multiparametric flow data. So the center where I work, we collect, it's a real-world cohort, so we collect large numbers of adult atopic dermatitis patients with a wide range of disease severity. And interesting, as you see here, we actually have quite a lot of overrepresentation of Asian patients, in particular East Asian and Southeast Asian patients in this cohort. And so we essentially set out to develop a panel for these cells, and we used essentially a cohort of atopic dermatitis patients with controls. So we have a healthy group, n equals 9, and then we actually just threw in, for comparison, a patient group with Dupi under remission. So not an ideal study design, but we wanted to be able to test for these markers in patients who had achieved a high EASI response. This is 1.5 years on Dupi with a mean EASI response, whereby they were under 5. So using traditional multiparametric flow cytometry, we're able to confirm, as others have shown, that there's in the skin homing population, so I'm showing you HLA-DR on the top as an activation marker, and on the x-axis here, CLA as a marker of skin homing T cells. We see that in atopic dermatitis patients, the cells homing to the skin are activated, and in fact, these activated T cells do not completely normalize, remain elevated even in these treated patients with clinical remission, both in the CD4 and in the CD8 populations. When we looked at CRTH2, interestingly, we found that they were really only detectable and high in the skin homing T cells of active atopic dermatitis patients. We were also able to show and to confirm really that IL-13 Th2 cell populations also remain significantly elevated following Dupixent exposure. So we see them high, and we see that they appear to be decreased, but do remain elevated above healthy controls in the skin homing compartment of these Th2 cells. So we wanted to dig a little deeper into this data set and essentially performed unsupervised high-dimensional analysis on the same flow data that we've just looked at, and essentially subsampled equal numbers of subjects from each of these 3 groups for concatenation. And I'm showing you here an illustrative pipeline using the UMAP for illustration, the cluster generation using FlowSum. This is all done on FlowJo package analysis. And here what I'm showing you is the MFI per cytokine per cluster of these 18 clusters shown here for cytokines. When we looked at these populations and used Cluster Explorer, we actually sorted the frequency of these clusters per group, shown here at atopic dermatitis, healthy controls, and this group on Dupi with clinical remission. And with these stars, I'm showing you these populations that came out as significantly different between health and disease. And when we dig a little bit deeper into these populations across the groups, we find that, interestingly, we see these populations of Th2 cells, which are GATA3 high and skin homing, some of which persist despite that remission. We also see that we do see CD4 T cells expressing CRTH2 high, so these Th2A-like cells, but interestingly not activated. And we also found surprising findings where we weren't expecting to look for naive T cells, but we also see populations naive T cells, interestingly, highly activated, expressing CCR6. And we see here in the middle a population expressing low levels of CRTH2. And we were surprised to see these populations are still learning about them. But most importantly, what we found was a very sort of pathogenic effector T cell that was a CD8 memory T cell with a high level of CLA, GATA3, homing to skin, and with HLA-DR intermediate to high, so activated cells that also seem to persist despite that clinical remission. Our cytokine panel shows that we find the expectedly IL-13 producing cells also homing to skin. We find these polyfunctional Th2 clusters with co-expression of IL-2 and IL-13, showing that these cells can also persist despite clinical remission. And we see a very similar cluster in CD8 T cells with these polyfunctional skin homing T cells also appearing to persist despite that clinical remission. So coming back to our hypothesis-driven approach, we wanted to examine these CRTH2 positive clusters in this analysis. And so here we've grouped together all of the CD4 T cells expressing CRTH2. And we were able to show that actually in line with our previous traditional analysis that we see this elevated population of CRTH2, Th2A cells, only elevated in AD. We can see that in the memory as well as in the naive T cell populations. However, when we look at these, and this is looking at skin homing now. So we also see skin homing Th2A elevated in only an active AD. Interestingly, when we look then at the CD8 TC2A population, we see skin homing, CRTH2 positive, CD8 T cells, active in disease, but also seemingly elevated above healthy subjects in the clinical remitted cohort. So in summary, we have shown that using these available biosamples and clear limitations to the study design, that using traditional multiparametric flow cytometry, that we see and confirm that skin homing type 2 T cells in patients' blood produce higher levels of 4, 13, and 2, that IL-13 producing cells remain higher during clinical remission with Dupilumab above healthy subjects, despite appearing lower than the untreated group, that highly activated skin homing T cells can persist in remission. And we see that the numbers of skin homing Th2A-like cells are comparable to healthy subjects in patients under treatment with Dupilumab, in contrast to the recent findings in skin. Then when we used our high-dimensional analysis, we can show that activated memory skin homing Th2 cells expressing high levels of GATA3 but very low levels of CRTH2, we see these are only activated in that active disease group, but it seemed to be comparable to healthy subjects under remission. We see that there are these naive cells, which we're still trying to understand. We also see activated memory GATA3 TC2 cells that are active in AD, and that seem to remain elevated in patients under remission versus healthy subjects. We see these polyfunctional T cells where IL-2 co-expressed with IL-13 may drive some persistence or resistance to treatment, and in particular showing that the CD8 population of co-expressing polyfunctional cells seems to remain most significantly elevated above the healthy subject group. And when we looked at these Th2A, CRTH2 metaclusters, we found that they were only elevated in that active AD group, while in contrast, when we look at this TC2, the CD8 CRTH2 metaclusters, we see that they do seem to remain elevated significantly above the healthy subjects, despite patients achieving clinical remission. So the role of these pathogenic effectors in the skin versus the blood, and their dynamic relationship with disease and also treatment response remains to be fully explored. And we are interested in this high-dimensional analysis of this flow data and its ability to help refine our understanding of disease. I'd like to thank my team, Zofia Alakaverdi, Frank Dupree, Gaurav Isola, Harshita Patel, for the work that they've done towards this presentation. And a special thanks to our funders, and I'd like to highlight again that there is a Canadian Research Fellowship available. If you are interested, it's a funded fellowship to spend 1 year learning atopic dermatitis methodologies. And of course, master's, PhD, and postdoctoral candidates are always welcome. Thank you very much. Right, and moving right along. It's really my pleasure to be standing at this podium and next to introduce Dr. Yamamura. So Dr. Kazuhiko Yamamura is an assistant professor of dermatology at Kyushu University Hospital in Fukuoka, Japan. Atopic dermatitis is one of his areas of focus. In addition to his other publications in peer-reviewed journals, he co-authored 2 articles on atopic dermatitis in 2022, The Dawn of a New Era of AD, and the identification of functional DOC8 gene polymorphisms associated with the disease. Thank you very much.
Thank you for introducing me, Caroline. It's a very honor for me to present here. I'm Kazuhiko Yamamura. Today I'm going to present the role of OX40 ligand axis in atopic dermatitis. This project was supported by Astra's Foundation for Research on Metabolic Disorders in 2019. Oh, sorry. OX40 is a co-stimulatory molecule transiently expressed on activated effector T cells and regulatory T cells. The ligand for OX40, OX40L, is basically expressed on APC cells such as B cells, dendritic cells, and Langerhans cells. The ligation of OX40, OX40L affects T cell responses, clonal expansion, differentiation, and the generation of memory T cells. It has been reported that TSLP, the primary OX40 ligand inducer, is highly expressed in atopic dermatitis skin. As you can see, TSLP is highly expressed AD regional skin. Recently, much attention has been paid for OX40 signaling in AD because blocking OX40 signaling has induced progressive clinical improvements in moderate to severe AD. As you can see, 3 biologics have been developed for OX40 signaling, for blocking OX40 signaling. Locatinlimab and GBR-H30 is for blocking OX40. KY-1005 is blocking for OX40 ligand. This graph is, the graph shown here is from locatinlimab. As you can see, around 60 to 70% of EZ are reduced by the treatment of locatinlimab. Surprisingly, when quit the treatment of locatinlimab, the improvement has continued after at least 5 months. So we sought to clarify the role of OX40 ligand axis in AD. First, I stained OX40 ligand in AD skin compared to healthy controls. As you can see, in AD regional skin, OX40 ligand is highly expressed in the epidermis compared to healthy subjects. To investigate what molecules is important for this induction of OX40 ligand, I did the culture assay using normal human keratinocyte, cultured with the following cytokines, such as interferon gamma, IL-4, IL-13, IL-70A, IL-70C, and 22. Then found IL-13 most strongly induced OX40 ligand, also TSLP. Next, I stained OX40 in AD skin region, and also found OX40 is highly expressed in AD skin compared to healthy normal skin. As you can see, many types of inflammatory cells infiltrated in AD skin, such as CD3 T cells and FOXP3 positive Tregs and CD11C positive dendritic cells and FcERI positive mast cells. So in the next step, I'd like to define what type of cells express OX40. As you can see, CD4 positive cells and FOXP3 positive cells co-expressed OX40 in AD skin. So when it counts, around 30% of CD4 positive cells and around 70% of FOXP3 cells were positive for OX40 in AD skin. CD8 T cells did not express OX40. So next, I did the flow cytometric analysis to define the OX40 expression in circulating cells. PBMCs were obtained from healthy controls and AD patients and analyzed OX40 and OX40 ligand expression by flow cytometry. Then I found the OX40 ligand expression is basically expressed in APC cells, VSS, monocyte, dendritic cells, but there are no differences between healthy control and AD patient. On the other hand, in CD4 T cells and Tregs, there are big increase in AD patient. CLA, cutaneous lymphocyte associated antigen, is specialized for skin harming and represent the main population in AD T cells. In AD patient, CLA positive CD4 T cells and Tregs are also big increased compared to healthy controls. And also importantly, CLA positive OX40 positive Tregs are clinically correlated in the disease severity in AD patient. Whereas CLA positive OX40 positive CD4 positive T cells are not. So, in next step, I did the functional assay to investigate the impact of OX40 ligand in CD4 T cells and Tregs in AD patient. CD4 T cells and Tregs in PBMCs were separated by max sorting and cultured in the presence or absence of OX40 ligand under the stimulation of TCR, then measured gene expressions by PCR. So, Th2 cytokine like IL-4 and IL-13 increased in AD patient compared to healthy control. But importantly, IL-10, the most anti-inflammatory cytokine, is reduced in the presence of OX40 ligand in only AD patient. In support of this, it has been reported that plasma IL-10 levels are higher in moderate AD patient and lower in severe AD patient. So, finally, we conducted RNA-seq analysis to characterize more broadly these gene expressions. Then I found OX40 OX40 ligand interaction in human Tregs decreases immune regulatory marker expressions and promote the Th2-like inflammatory phenotype. Gene set validation analysis shows that negative regulators and Th2 cytokine are downregulated in AD Tregs. Th1 cytotoxic genes such as CXCL10, STAT1, CXCL9, granzyme H, CCR2, granzyme K, and FOX1 are decreased in AD Tregs. And additionally, Th2 inflammatory genes such as IL-9, CCL20, and CCL17, ICOS, CTLA4, IL2RB, CCL22 were increased in AD Tregs. In conclusion, we found that OX40 ligand signaling reduces the IL-10 and other negative regulators in AD Tregs, then promote Th2-like inflammatory. So the OX40 signaling enhance this immune inflammatory loops in AD patient. I'd like to say thank you for my special collaborators and very kind coworkers, the Rockefeller University, Professor James Kruger, and icon of medicine of Mount Sinai, Professor Emma Guttman-Yoshiki, and many kind of coworkers. That's all I have to say. Thank you so much.
Thank you. That was a very interesting presentation. Thank you so much. So next up, it's my pleasure to introduce Dr. Patrick Brunner, who's an associate professor of dermatology at the ICANN School of Medicine at Mount Sinai in New York City.
Caroline, I think we have a break first.
Well,
I
then,
think there is a break, and then
starting
hold your
hold your horses, coming soon to a podium near you.
yeah 15
Enjoy the break.
minutes break.
So I think we're going to get started, folks. I'm going to bring you all back into your chairs. I know you're really looking forward to our next talk, and we have a packed session here. So if everyone can come and take a seat. Intermission is officially over. Let me get your page ready. Okay, are we all seated? Are we all ready for this next part of the talk? Yeah, please do. Very good, that was great. So, thank you very much, and I hope you all had a nice break. We're very excited now to introduce Dr. Patrick Brunner, who, as you may have heard, is an associate professor at the ICANN School of Medicine at Mount Sinai in New York, where he's also the director of the Cutaneous T-Cell Lymphoma Clinic at the Kimberly Waldman Department of Dermatology. He's a clinician scientist with a strong interest in skin immunology and sees patients suffering from primary cutaneous immune malignancies, and also has a general interest in immune-mediated inflammatory diseases such as vitiligo, atopic dermatitis, alopecia areata, and scarring alopecias. His research is aimed at a better understanding of the tumor immunobiology in cutaneous lymphomas and to develop treatment modalities for this patient population. So without further ado, Dr. Patrick Brunner.
Thank you so much for the kind invitation. Sorry, I left my voice on the airplane, but otherwise I hope you can hear me. And I did 5,000 COVID tests, believe me. Okay, so thank you so much for having me here. I'm very excited to be here in Tokyo and at this wonderful symposium. And I'm very happy to talk about systemic inflammation in atopic dermatitis. These are my disclosures. So when we talk about atopic dermatitis, I think you're very well aware of the fact that this is a disease that usually starts very, very early in life and can become a lifelong burden. And when we talk about inflammation and the inflammatory burden, I think this might be one of the diseases or the disease where over a lifetime you might have the largest, or you could speculate that you might have the largest burden of inflammation because it starts so early, much earlier than other chronic inflammatory skin diseases such as psoriasis, for example. And when we talk about systemic inflammation in atopic dermatitis, when we have a look at the blood, you see many, many markers to be upregulated in the peripheral blood of atopic dermatitis patients, led by CCL17, which is a very well-established activity marker in atopic dermatitis. But there are many, many other markers, increased inflammatory markers, increased in the peripheral blood of especially moderate to severe atopic dermatitis patients that are associated with a wide variety of inflammatory axes and processes. And In this study, for example, when blood samples are clustered in comparison to healthy controls, it's clear that atopic dermatitis is very distinct, and several inflammatory markers are highly upregulated in the peripheral blood of those patients. And these changes start very, very early in life. And we now know that especially, or even in infants and newborns, there's already a disbalance in the overall inflammatory landscape in the peripheral blood with a stronger propensity towards a type 2 immune response. And this gives you an increased risk of developing atopic dermatitis. So this is a process that starts already very early in life and is measurable in the blood of those infants. And this is a very nice study looking at inflammatory pathways in the peripheral blood. And already in children, already in infants, there are several immune pathways activated very early in life. And over a lifetime, children, adolescents, and adults, you get some intensification of these inflammatory pathways that start very early in life. Now, the question is, of course, you see all these inflammatory mediators in the periphery, so where does that come from? On the one hand, it could be some overflow from skin inflammation, and on the other hand, it might come from somewhere else. Sort of atopic dermatitis is a multi-organ disease. And of course, we all know that there are several atopic diseases associated to atopic dermatitis, as we see here in the atopic march. You're very, very well aware of food allergy, asthma, and rhinitis being associated with atopic dermatitis and leading to the characteristic atopic march. This is, of course, a cross-section of a population, the so-called atopic march, and the situation in real life is much more complicated, and that you have this sequence of skin versus food allergies versus airway inflammation happens only in a minority of patients, and associations are much more complicated in different populations. But overall, I mean, there's this clear association with multi-organ involvement of type 2 inflammation. So for sure, there's a multi-organ component to it that is all, of course, immune-mediated by type 2 inflammation. But there's also a tight correlation with systemic inflammation and the skin, which I think can be demonstrated by the mere fact that many of those markers are tightly correlating with overall skin inflammation. So, for example, when you look at the SCORAD, the skin score, high SCORAD, there's a lot of skin inflammation or skin involvement of atopic dermatitis. You see that several markers, for example, endothelial activation or other markers, are positively correlated in the serum of those patients. So there's a clear connection with the overall skin burden with the levels of those inflammatory mediators in the peripheral blood. And when you do sort of a negative control check for the BMI, for example, that can also be associated with systemic inflammation, you see that those markers do not correlate. So for several markers, there are clear correlations of the overall amount of skin inflammation with what's going on in the blood. And we also we found that there's a correlation of CRP, for example, with severity in disease. So the more skin disease you have, the higher you get low levels of C-reactive protein in the peripheral. And you all know that, for example, LDH is also a marker of overall disease severity in atopic dermatitis. So why would that all be of relevance? It's of high relevance, of course, because elevated CRP levels, for example, are a very high risk factor for cardiovascular disease. And in this nice study, it has been demonstrated that not only in psoriasis, where systemic inflammations and cardiovascular disease is very well established, but also in atopic dermatitis, there's an increase in cardiovascular disease, as evidenced here by atherosclerotic plaques, by calcifications in the coronary arteries. So these segments are higher both in AD and in psoriasis when compared to controls, at least in moderate to severe forms of the disease. So there's a clear association with cardiovascular disease. And there are different studies, some retrospective, some showing connections, some don't. But I think the overall sense is that in atopic dermatitis, in many investigations, you have a clear association of cardiovascular disease with atopic dermatitis. And why, or what's the connection here? I mean, all those mediators that circulate in your blood, of course, it's conceivable that endothelial cells get activated by all those markers. Because what is happening in atherosclerosis, what is happening in cardiovascular disease, at the end of the day, it is also an inflammatory, it's also an immune-mediated condition. And when you have chronic inflammation, or it's very clear that, or it's very well known that chronic inflammation can accelerate atherosclerosis because you have a repetitive sort of vascular injury with all those mediators that then leads to impaired vascular relaxation, increased leukocyte adhesion, increased endothelial permeability because you need leukocytes to migrate out into the blood vessel to mediate atherosclerosis, and then you have the generation of a pro-thrombotic state. So there's, from a pathophysiological standpoint, I think that that connection is quite conceivable. And how can this be measured? So when you look at endothelial cells, and when they get activated, they release so-called microparticles, which are small blebs that you can measure in the peripheral blood. And those microparticles give you an indication of endothelial activation of endothelial stress. And I think you can clearly see here, both in platelet-derived microparticles as well as endothelial-derived microparticles, there's a clear increase in atopic dermatitis patients compared to healthy controls. And this is a good surrogate marker for endothelial activation and vascular injury. But also the cells that are circulating in moderate to severe atopic dermatitis patients show some form of activation. I mean, Dr. Jack has very nicely shown us her data. There are also data on ICOS, which is an activation marker on T cells, and those cells are highly activated in atopic dermatitis, even more so to match psoriasis and healthy control patients. So also those circulating cells are activated in atopic dermatitis patients. So now you might be skeptical and say, well, you know, all those associations between inflammatory markers in the circulation, how can you, I mean, there are associations, but, you know, correlation is not always causation. How does this all fit together? Of course, many of this evidence is circumstantial, but I think what is always a very good, you know, thing to look at is whether there's a dose response. And I think in this data, you very nicely see a dose response from mild to moderate to severe eczema. And here you can see increases in cardiovascular, not only not surrogate markers, but real endpoints like ischemic stroke, myocardial infarction, or cardiovascular death. And here you can see an increase with worsening atopic dermatitis. So I think that data shows that the burden of inflammation in atopic dermatitis patients correlates quite convincingly, I think, with overall cardiovascular outcome. So when we talk about the burden of inflammation, the burden of inflammatory markers in atopic dermatitis, I think one thing that is also very important to know about atopic dermatitis is that clinically normal appearing skin, at least in moderate to severe patients, is not actually total normal skin. It's clinically normal appearing skin still harbors quite substantial amounts of inflammatory mediators. As you can see in this study, normal skin almost has no interleukin-13. There are lots of interleukin-13, of course, in lesional skin of atopic dermatitis, but still in non-lesional or clinically normal appearing skin, there's still a substantial amount of this pro-inflammatory mediator. And this is true for several others. So clinically normal appearing skin still harbors some inflammatory processes, which of course adds to the overall burden of inflammation, at least in moderate to severe patients. We had an interest in looking at what's actually happening in skin after up to 1 year of Dupilumab treatment. You know that in atopic dermatitis patients, you can treat it now very nicely with targeted treatments, but once you stop the treatment, the disease usually comes back, and this is mediated via tissue-resident memory cells that persist even after 1 year of Dupilumab treatment. So those are T cells sitting in your skin, the Th2A cells that Dr. Jack has mentioned, that you can't get rid of even with long-term treatment. And by looking at the skin and by looking at inflammatory mediators, these inflammatory mediators also still persist after 1 year of treatment. So this is a volcano plot showing a skin proteomics study where you get lots of the upregulated inflammatory markers in untreated atopic dermatitis, skin versus healthy controls. And after 1 year of Dupilumab treatment, there's still interleukin-13 present, which of course cannot signal because Dupilumab blocks the downstream effects. But you can imagine once you stop that treatment that the atopic dermatitis skin disease can quickly waken up again, and it's obviously necessary to treat those patients long term. Important in those patients, you also get some increased inflammatory mediators. I'm sorry, it's a little too small to see, but still also in the peripheral blood, there are remaining inflammatory mediators even after 1 year of Dupilumab treatment, which of course also adds to the overall inflammatory burden, especially when treatments are stopped again. So this overall inflammatory burden in atopic dermatitis, of course, necessitates long-term treatment approaches. But what about, curing those patients or getting rid of this disease memory? I mean, we are, of course, far away from that. There are some data in psoriasis that with P19 blockade, you can modulate the disease memory, and with novel targeted treatments, of course, the hope is that you can get long-term disease modification. But we had a look at patients that spontaneously cleared their disease after moderate to severe atopic dermatitis during their childhood. And interestingly enough, there was some upregulation of tolerizing factors in T cells of those young adults that spontaneously cleared the disease. And maybe this is also one step towards long-term disease modification, which of course will be the ultimate goal of treating atopic dermatitis patients. All this inflammatory burden, of course, adds to various comorbidities, which I don't want to go into too much into detail, but the interesting thing is that many of those comorbidities are inflammatory in nature, and you know that atopic dermatitis patients do not only have cardiovascular, but they also have, for example, neuropsychiatric diseases, and it's now getting more and more clear that neuroinflammation can have a negative impact on your brain, and I would be surprised if like ADHD and other neuropsychiatric associations with atopic dermatitis would not be associated with all these inflammatory mediators. With this slide, I would like to stop or sum up. I think atopic dermatitis has very well emerged into a disease with multiple inflammatory comorbidities. You get lots of peripheral activation, including T cells, and future treatment approaches, of course, will need to focus on systemic therapies for moderate to severe disease. With this slide, I would like to stop, and thank you so much for having me here. Thank you so much.
Thank you so much for that great presentation. We have really an all-star cast here. So up next is Dr. Helen Hay, a resident in dermatology at Icahn School of Medicine, Mount Sinai, in New York again. And Dr. Hay has published several molecular and proteomic phenotypic studies in atopic dermatitis, as well as other skin conditions. And in fact, she was the first to describe cutaneous single-cell RNA sequencing profiles in atopic dermatitis. And she received her bachelor's in biological engineering at MIT and her MD in New York. So thank you very much, and welcome to the podium, Dr. Hay.
Thank you so much for that kind introduction. So today I'll be discussing early biomarkers and predictive factors for atopic dermatitis and Atopy. I have no disclosures. So we all know that AD is really common overall, but it is particularly prevalent in the pediatric population where it affects up to 20% of children worldwide, of which over half of the cases occur in the first 2 years of life, and the vast majority occur before the age of 5. Some of the strongest risk factors for developing AD include family history and filaggrin mutation status. And there's also variable data as to the efficacy of preventative strategies against AD in infancy. For example, the regular use of preventative emollients was shown in some studies to reduce AD, but not in others. We're also becoming increasingly cognizant of the complex pathogenesis of AD, involving many of the things we've discussed, immune dysregulation in the Th2 axis mostly, but also others as well, and barrier defects in terminal differentiation, lipid metabolism, and synthesis. And because of the high prevalence of AD at such an early age, it would be really valuable to see if there's any markers that can that represent these processes or underlie these processes that could be detected either in early AD or could even precede the development of AD, as that would really help us further refine our definition of what a high-risk AD patient is and potentially have more targeted preventative strategies for those patients. So first, I want to go over a couple of studies that came from our lab in which we really sought to define the skin and blood signature of early AD at a protein, molecular, and cellular level. So here I'm showing transcriptomic profiling with the immune signature with this heat map of AD and control subjects across different age groups, namely infants, children, adolescents, and adults. And for each of these, we have columns corresponding to controls, non-lesional AD and lesional AD samples. Here, red is higher gene expression and blue is lower. And because the focus of this talk is on early AD, I'll be mostly focusing on the infant group here, which, as you can see, already has robust activation of many immune-related genes, many of which persisted to older age groups as well. And some of these genes included markers of general inflammation, such as MMP12 and ICOS, Th2 cytokines, of which are many, but including IL-13, CCL13, 17, 18, and Th22 cytokine, IL-22, as well as the S100s that are co-modulated by Th17, with decreases in negative regulators such as IL-34 and IL-37. There are also some genes that actually show the most marked dysregulation or highest fold changes in the infant group compared to the older age groups. And some of these genes included the itch cytokine IL-31, Th17 cytokines such as IL-17A and F, and IL-5 and IL-33, which are involved in the initiation of atopy. And in contrast, Th1 chemokines such as CXCL9 and 10 really didn't become elevated until adulthood, and this makes sense given that they're often considered markers of chronicity. So I also want to move on to discuss barrier-related genes as depicted in this heat map. And as you can see from the blue color, once again focusing on the infant group, there was pronounced downregulation of many barrier-related genes. And the majority of these genes in the infant group were related to lipid synthesis and metabolism, whereas the genes related to, let's say, terminal differentiation, such as filaggrin or cornified envelope components, really did not become downregulated, once again, until older age groups. So it appears that the main barrier defect in early AD seems to be in the lipid composition. Now we want to see if these findings in skin can also be correlated in blood. So this is a flow cytometry study on the same group of patients in which we measured various cytokine-producing subsets in the peripheral blood of these patients. And I know these plots are quite busy, but I have boxes here highlighting significant comparisons between infants with AD versus controls. And as you can see, there is in infants with AD significant expansion of CLA positive, so skin homing, CD4 positive central memory T cells, and effector memory T cells. And then CD4 positive central memory T cells that that were positive for ICOS expression, reflecting mid-activation of T cells, were also significantly expanded in infants with AD in both the skin homing and systemic compartments. And similar to in skin, interferon gamma producing cells really did not show increases in the infant group. We really saw that later on in older age groups. But skin homing Th2 cells, as we've had a great talk about already, were significantly expanded in the infant with AD group. So these were cells that were positive for CD4, CLA, and IL-13. Moving on, we also performed a proteomic assay. So this is an O-link proteomic assay in which we measure over 350 serum proteins in the peripheral blood of 80 patients across different age groups. And here, the color of the heat map actually reflects the magnitude of the fold change versus controls normalized across the age groups. So just like in skin, we saw increases in CCL13 and 17, and then there were some systemic markers that actually had the most pronounced upregulation in the infant group compared to the other age groups, and these included, once again, MMP12, CD4 and 5, which are T-cell markers, the IL-17C, an innate immunity marker, as well as PI3, which is a marker of Th17. And we just had the excellent talk by Dr. Brunner about the systemic inflammation that's present in AD, and we do see that some of that systemic inflammation is already detectable in very early AD. I also want to discuss a technique that has really proven instrumental to our study of early and predictive biomarkers of AD, and that is tape stripping, which is a skin sampling technique in which tapes are consecutively applied and removed to the same area of skin, and that material is then analyzed via various platforms. And compared to biopsies, the advantages of tape strips are many. They don't cause infection or scarring, they are painless, and they're much more tolerated in the pediatric populations where biopsies are typically not feasible. So we perform transcriptomic profiling on using tape strips taken from infants with AD and control infants. And similar to biopsies, tape strips are actually able to capture the dysregulation of many immune-related genes. I won't go through each of them one by one, but here are some examples here. And also was able to capture the downregulation of many barrier-related genes as well. So we also did we also built a gene classifier in which we were determined to see which markers could potentially discriminate infants with AD compared to control infants. And here are the genes by combining the top dysregulated genes between these two groups, we found that we were able to discriminate them with almost 100% accuracy. And even more notably, IL-34 by itself was the best single gene classifier with an area of under the curve of 0.94. So it seems that perhaps IL-34 levels in tape strip could be really helpful in distinguishing infants with AD compared to controls. So it could be a very useful diagnostic tool for early AD. Okay, so I want to change gears now and discuss a couple of longitudinal studies that sought to see if any of these markers can precede the development of AD and potentially have any predictive value for the onset or course of AD. So first I want to discuss this very important study by Jacob Tyson's group in which term and preterm infants were enrolled and followed from birth to the age of 2 years, and tape strips were collected at birth and at 2 months of age. So they analyzed the tape strip for various markers, including CCL17. And here are just some plots that show the cumulative risk of developing AD overall, as well as specifically moderate to severe AD on the left and right, respectively, for patients with elevated CCL17, as depicted by the yellow line, and normal CCL17, as depicted by the blue line. And as you can see, elevated CCL17 was associated with the increased risk of AD overall with an adjusted hazards ratio of 1.85, and this risk was even more pronounced in the case of moderate to severe AD, which had an adjusted hazards ratio of 4.65. And looking at this data another way, we see that at 2 months of age, tape strips showed elevated CCL17 levels in patients with moderate to severe AD compared to those who would not develop AD. And this trend was seen for both onset in early infancy and late infancy, as CCL17 levels at 2 months were significantly higher in patients who would develop AD before and after the age of 6 months compared to those who would not develop AD. So just quickly going over some other findings from the group. Besides CCL17, IL-8 and IL-18 were also associated with increase of moderate to severe AD. Uricanic acid levels were associated with, or decreased uricanic acid levels was also associated with increased risk of AD overall. Among the preterm cohort, only CCL17 was associated with increased AD risk, and this was with borderline significance. And at birth, tape strips were also collected, but there were no reported associations between tape strips at birth and increased risk of AD. So from the same cohort, the authors also did a case control study in which they took 44 patients with AD who developed AD in the first year of life and 44 who did not develop AD. And a major focus of this study was in the lipid profile. So towards the right 4 plots here, we're showing the 4 lipids that were significantly altered between those who would develop AD and those who wouldn't. And among them, phytosphingosine was a single lipid that had the most marked decreases in AD versus non-AD. And they also looked at lipid ratios, so ratios between sphingosine bases and ceramides of various chain lengths. And they found that these are the 10 lipid ratios that were most different between AD and non-AD. And overall, there was a trend towards higher concentration of shorter chain lipids in AD compared to non-AD. They also did a little bit of predictive modeling to see what combination of various markers or factors could confer a higher risk of developing AD. And among the lipids, phytosphingosine again emerged as a single lipid that was the most predictive with a maximum accuracy of 75.6%. And by combining the 5 lipid ratios that were most different between AD and non-AD, they were able to achieve an accuracy of 89.4%. So it does seem that the lipid composition could be different in patients at high risk of AD, and analyzing the lipid composition could provide some insights into which infants have a higher risk of developing AD. So I also want to discuss another very important study by Daniel Leung's group, in which this was a prospective study where 111 infants were followed from birth up to 2 years of age, and tape strips were collected once again 2 months and analyzed for cytokines and lipid levels. And they found that patients who would come to develop AD had significantly higher levels of IL-13 and TSLP compared to those who didn't, as well as decreased protein-bound ceramides and increased unsaturated sphingomyelins. They also looked at which permutations of markers and factors had predictive value for AD, and they found that TSLP and IL-13 elevations were respectively associated with an odds ratio of 4.1 and 7.7 of developing AD. For TSLP, the combination with family history made that risk even more pronounced. But most notably, by combining family history, elevated IL-13, decreased ceramides, and increased sphingomyelins, they were able to achieve a odds ratio of 54, which was very impressive. Of note, they also looked at filaggrin degradation products, including uricanic acid levels, for instance, but they did not report any appreciable differences in filaggrin degradation products between AD and non-AD. Okay, so finally, I want to discuss another very interesting study. And here, 87 infants with known diagnosis of AD was enrolled, and 126 serum proteins were measured at birth, 1 year later, and 3 years after that, with the goal to see if any systemic markers would provide any insights or provide any information in who might be at risk of developing more severe disease. So here, they correlated all these markers with SCORAD as the measure of disease severity, and found that caspase-8 had the highest correlations with SCORAD, but also very high correlations were found for IL-13 and TARC or CCL17. And they implemented this forward selection modeling approach in which they identified the 18 serum proteins whose levels at baseline was most predictive of change in the SCORAD over time. So on the plot on the right here, as you can see, the predicted change in SCORAD from this model actually correlated really well with the actual change in SCORAD, and this was also validated over 100 iterations. So finally, I'm just going to conclude with a couple of higher level learning points from some of these studies. We found that skin and blood profiling is able to capture immune and barrier abnormalities in early AD, some of which persisted into adulthood, some of which were actually the most pronounced in infancy, including many markers of Th17. Tape strips are a really useful tool for studying early and predictive biomarkers of AD, and IL-34 levels in tape strips in particular may be really helpful in discriminating AD versus controls in these early ages with a high degree of accuracy. Th2 elevations, they're present early in AD. They've been shown to possibly precede the development of AD and therefore confer a greater risk of AD. And in patients who are diagnosed with AD already, may also provide insights on who might develop more severe disease versus who might recover or improve. And the main barrier defect in early AD seems to be in the lipid composition, where specific changes such as decreased ceramides or decreased fatty acid chain lengths, for example, could provide some insights into which patients may have a higher risk of developing AD in the future. So overall, immune and barrier biomarkers, perhaps in conjunction with some other factors such as family history, filaggrin mutation, seems to have some value in predicting the onset and disease course of AD. But I think there's still definitely areas of further exploration in the future as well. For example, I'd be curious to see if IL-34 or Th17 markers that are arising so early in the disease process has any predictive value for disease onset, or if there's any biomarkers that can potentially predict persistence past infancy of disease or into adulthood, or a response to certain therapeutics, whether it be good or poor. And I think from our studies and others, we have some of the answers to these questions or some hypotheses, but longitudinal studies would definitely be helpful. But overall, I think this is a very exciting area, and hopefully some of these findings in the future can be incorporated in a clinical setting at some point as diagnostic tools that can help with identifying high-risk AD patients in early age groups, and also in intervening to mitigate that risk at early stages. So with that, I would like to conclude the presentation, and thank you to the IEC for inviting me to speak today, Dr. Guttman for her continued mentorship, and our great team at Sinai and all of our collaborators.
Thank you very much. What a wonderful synthesis of such a large body of work. So it's my pleasure to introduce the star, not just a rising one, this is the star in atopic dermatitis, Dr. Guttman. And so as a system chair of the Department of Dermatology and Alman Professor of Dermatology and Immunology at the Icahn School of Medicine in Mount Sinai, she's also the director of the Center of Excellence for Eczema and the Laboratory for Inflammatory Skin Diseases. Dr. Guttman also co-founded the International Eczema Council and is its immediate past president. Her major research focus areas currently are atopic dermatitis and alopecia areata, and it's my great pleasure to introduce her today. Thank you very much.
Thank you so much. It's such a pleasure. My first talk actually was in Kyoto, my first talk ever. And this is so nice to be talking here today. And I have to say also that I'm super proud of Helen. I'm sure you'll hear much more from her in the coming years. She's only a second-year resident, but will be staying as faculty, and she's definitely a rising star. So after her lecture, I hope I'll educate you some more how biomarkers were so valuable in the therapeutic development in atopic dermatitis. Now, Caroline, how do I move the slides? So my disclosures, I'm really proud to be part of the therapeutic development that is ongoing for atopic dermatitis, but I don't have any financial gain from any product, and all the dollars are coming to Mount Sinai. So as you know, up to maybe a few years ago, psoriasis was perhaps the best example of translational research and translational development, but I think I want to think that atopic dermatitis, it's getting maybe a center stage as maybe the best model of a translational disease. And it was a very long road to get to where we are today, many years, many failures as well. So how did we get to this point in atopic dermatitis? It started with bench studies of pathogenesis that were really instrumental, and they included biomarkers, both in skin and the blood. You heard how important the blood biomarkers are as well. And these were really important in order for us to formulate a pathogenic hypothesis and to generate the first clinical trials with targeted agents that were missing for our patients that were getting just immune suppressants just until a few years back. And those also included skin and blood profiling that were important to generate biomarkers of therapeutic response. And again, there were multiple cycles for maybe one success story. There were 9 failures to generate the novel therapeutics. And like I tell my mentees in life, not only successes, but more importantly, failures are really important to frame the pathogenic concepts and therapeutic directions. Now, as you heard, in atopic dermatitis, we shouldn't just think about the lesional skin. The non-lesional skin is also very important, and also the blood is important as well. And when we think about a biomarker model, we have to have an integrated model of atopic dermatitis in which all of these compartments will be considered. So how are we developing a translational medicine approach in atopic dermatitis? First of all, I have to tell you that atopic dermatitis is much more difficult to quantify clinically than psoriasis, right? Psoriasis, we have placebo responses of only 3 to 5%, but in atopic dermatitis, placebo responses can be soaring up to 35% in some studies. So these studies are a little bit subjective, right? EASI scores, SCORAD. We need maybe better objective means to be able to quantify the disease. And defining atopic dermatitis-specific biomarkers in both skin and blood can help us, first of all, identify pathogenic pathways and identify new treatments, and also develop precision medicine approaches because the disease is so heterogeneous so that we really understand which drug for which patient. And we all know that skin profiling is the gold standard, and particularly in biopsies, but these are not always handy, and blood profiling may still be very helpful to really stratify the patient and for therapeutic selection of patients. And as you heard from Helen, development of minimally invasive approaches is important, both in adults, but particularly in children, where it is hard to sample the skin. And tape strips may provide a useful means to investigate biomarkers in a pediatric setting, and also in large clinical trials when we need to get biomarkers in all the patients. You cannot ever sample all the patients in a study by biopsies, but you can do that using tape strips. Or in longitudinal studies when we need to take multiple skin sampling, and again, these are hard to do just using biopsies, so it may not be as feasible. Now, we all know the old-style treatments, right? Cyclosporin, methotrexate, even phototherapy. These treatments were non-specific, and as you can see here, they targeted everything, right? T cells, B cells, dendritic cells, mast cells, and others. And because of that, they were associated with multiple side effects. So to get our patients better treatments and safer treatments, we needed to define more specific biomarkers that will be able to get us closer to refined therapeutics, to more specific treatments that will not have those side effects. And Dupilumab was really instrumental in opening the door to such therapeutic development for atopic dermatitis. So you heard about Dupilumab already multiple times. Dupilumab is an antibody targeting the IL-4 receptor alpha. And because of that, it targets not only IL-13, but also IL-4. And both IL-4 and IL-13 are both involved in the barrier dysfunction in atopic dermatitis. They inhibit filaggrin, loricrin, tight junctions, and also lipids, all of them important in atopic dermatitis. Now, my lab participated in the biomarker study of Dupilumab, both the phase 1 biomarker study and then the standalone phase 2 biomarker study. And this study that Robert Bissonnette was also part of it was conducted in 5 sites, and my lab analyzed the biomarkers. It was 27 patients that started on drug, 27 patients started on placebo. Both lesional and non-lesional skin were sampled at baseline, week 4 and week 16. And here you can see a heat map of gene expression. And when you look carefully, and red is upregulation, blue is downregulation, you can see that Dupilumab really modulated significantly multiple markers. Yes, you see there the Th2 markers like CCL17, CCL22, CCL26, but you see beyond that, you see modulation of Th17 and Th22 markers like the S100s. But importantly, Dupilumab did not modulate the Th1 pathway. And hold that thought because it's an important differentiator from other molecules. Now, importantly, the million-dollar question is, can we target the immune system or a narrow pathway in atopic dermatitis and reverse that barrier dysfunction that our patients have? And the answer is yes. Dupilumab also reversed the barrier dysfunction in this study. And how can you tell? Look at the hyperplasia at baseline. And this is completely reversed to normal or to non-lesional level at week 16. The keratin 16 staining that typifies atopic dermatitis lesional skin, you see it's widespread in the epidermis. It's completely turned off only with Dupilumab. And the epidermal thickness of all the patient population, pay attention to 40% reduction at week 16. Already there is a major reduction at week 4. And what about filaggrin, right? The holy grail of atopic dermatitis. Look at the skipped expression of filaggrin at baseline, and that is normalized at week 16. So yeah, Dupilumab did reverse the barrier defects in atopic dermatitis. What about the systemic inflammation? So we also had a reversal of the type 2 immune abnormalities in the circulation. With Dupilumab, pay attention to TARC, CCL17, one of the best biomarkers of atopic dermatitis, and also PARC, CCL18. They are reduced significantly only with Dupilumab, not in the placebo arm. So to put it all in context, this study was super important because before the study, we showed that cyclosporine modifies biomarkers, but like I told you, cyclosporine is non-specific. So we couldn't really prove that immune hypothesis of atopic dermatitis. But what we see here is that Dupilumab impacted both the inflammation and the barrier dysfunction of atopic dermatitis, really positioning the Th2 axis and the leading cytokines, IL-4 and IL-13, as pathogenic in atopic dermatitis, cementing the disease as both reversible but also as immune-driven, very similar to psoriasis that now is focused on IL-17, IL-23, really opening the door to all the therapeutic development that is ongoing now. And I want to also point out, and we designed these graphs to just show how objective biomarkers are as compared to differences in easy responses. So pay attention here at week 4 at the difference that you see in the changes in the molecular profiling or the transcriptome versus changes in EASI. And also I want to point out that at week 4, patients so-called improve by EASI, but they actually exacerbate in the placebo arm in the molecular profiling. So it's a much better objective means to introduce in your studies, particularly early on. And again, at week 16, much larger differences in the molecular profiling. Now, let's move on. Another question is IL-13 antagonism equivalent to targeting both IL-4 and IL-13? And the answer is they are in the same ballpark. You know, studies are not done at the same time, so it's hard to compare. But this study is the molecular profiling with tralokinumab for 2 years. And you see here, this is a heat map, again, of gene expression studies. Look at tralokinumab, both lesional and non-lesional, and placebo. And you see that only with tralokinumab, red is turning to blue, and the same with blue turning into red. So downregulated genes are upregulated. And in this graph, you see the 0 line is the non-lesional, and you see that only with tralokinumab, the dysfunction in the lesional skin, both the up and down-regulated genes, are coming closer together over time, whereas that's not happening in placebo. And of course, the placebo was only 16 weeks. And here is the overall improvement in the molecular profiling or the transcriptome. Pay attention, again, exacerbation in the placebo arm early on. We never get that using EASI, right? We have inflated EASI responses because the best dermatologist cannot really quantify where the lesional skin begins, where the non-lesional ends. So you need some better objective means to quantify it. And then you see the gradual improvement towards 2 years, where you see almost normalization of the AD transcriptome. Now, this is an NIH study that we've done to show whether or not IL-22 is indeed pathogenic in atopic dermatitis, and I'm happy to say that we proved it as being pathogenic. Patrick was a leader in this study. And this study that we've done with the NIH was a small study, 60 patients, 40 started on drug, 20 on placebo. And when you look at, and I would have designed it differently today because we put the primary endpoint at week 12. We should have put it at week 20 because it's a slow responding drug. But in any event, you see that there is a difference, only it was not significant at week 12. But we saw a trend when we did the regression analysis. We saw that severity made a difference. So we divided the patients to moderate patients and severe patients. And then in the severe patients, look at that, we found significance at every single week, whereas we did not see significance in the moderate patients. These are the non-severe patients. And we asked ourselves, what does it mean? And luckily, we had biopsies in this study. And we decided to divide the patients based on baseline expression of IL-22, just a crazy idea that panned out. And this, I think, is the first study of personalized medicine in dermatology, not only in atopic dermatitis, because look at that. The patients with the high baseline IL-22, you see that the red is turning to blue, and basically at week 12, the lesional skin looks very similar to the non-lesional skin. That's not happening in the placebo arm of the high baseline IL-22. And unfortunately, the patients with the low baseline IL-22, we managed to get the patients worse. Blue is turning into red, so they worsen. But if you find the right patients, these patients improved really well, like this patient, an African-American patient with highly lichenified lesions that are very difficult to resolve. And not only the patient resolved the lesions, but she stayed clear 3 months after the study. And as you know, Leo Pharma now has an IL-22 receptor antagonist, that is now in studies, and I'm very excited to see what is happening with this drug, because I think it has a lot of potential, and you heard at the AAD, the late-breaking presentation. Now, another new kid on the block, another exciting target, OX40, there are several studies with both OX40 antagonism and OX40 ligand antagonism. I'll show the OX40 study that I was involved in the biomarkers. So what is OX40? So OX40 is primarily expressed by activated T cells and binds OX40 ligand on antigen-presenting cells. And this drug is a drug that started with Keio, and now Keio is partnering with Amgen on the development, and is in phase 3. And it now has a name, rocatinlimab, a little bit hard to pronounce. And it inhibits activated T cells, including but not only activated Th2 cells, inhibiting formation of memory cells. And this study was published in The Lancet. And I'm happy to say that I was involved in the development from the very beginning, when the company was doing a study in psoriasis. And I told them, no, you should go for atopic dermatitis. That's much better. And indeed, the study in psoriasis failed. It was a large study. But now the drug is moving forward in atopic dermatitis. And here, several doses of the drug reached significance, all of them, as compared to placebo at week 16. It was an interesting design, phase 1 of the study until week 16. Then until week 36, everybody got drug. And you see continuous improvement of all the drug doses. The placebo patients that were put on the higher dose started to improve. And most importantly, I think this is the first large study that shows durability of response. And look at this Kaplan-Meier plot. The EASI-75 responders were followed for another 20 weeks off drug. And you can see that the patients on the 2 highest doses achieved more than 90% maintenance of EASI-75. This is the only treatment I'm aware of that we see these large numbers of patients, not 1 or 2, but most of the patients on this drug with the higher doses maintaining responses, and we've seen that also in the clinic. So super exciting to now not only treat our patients effectively, but think about the next step, disease modification. And that's important not only in adults, but definitely in adolescents and children. And just to show you how the biomarkers fall very nicely in place here and show, give us more confidence. These are the biomarker, this is the biomarker study from these patients, and I was part of this biomarker study. And these are all the patients. When you do biomarker studies, don't show just responders. We want to see all the patients, right? So these are all the patients. And I'm not showing you here, but OX40 positive cells were eliminated in the upper dermis basically after 8 weeks, continuing to the withdrawal period. And these are biomarkers in both blood and skin. Look at the reduction of CCL17 that continues in the withdrawal period. IgE is continuing to go down through the withdrawal period. And the same for total OX40 positive cells in blood. And IL-22 also continues to go down. And this is a heat map of gene arrays done in the study. And what you see here very clearly, you see that only with drug, but not placebo, the lesional skin improves gradually towards week 16, but then continues to stay basically like the non-lesional skin throughout, whereas in the placebo arm, you do not see that. The red continues to be red. Pay attention also to changes in the non-lesional skin. This is something also quite unique. You see the placebo non-lesional skin gets worse, but you do not see that in the non-lesional skin with drug that improves actually a little bit. And another novel technique that we did here, we did a transcription deconvolution analysis to understand a contribution by cells, right? That's also important. And we looked at multiple cell types and how they changed during treatment. And pay attention that Th2 cells, Th17 cells, keratinocyte and dendritic cells are changing significantly with treatment. Now, as you heard from several speakers today, atopic dermatitis has multiple subtypes, is a highly heterogeneous disease involving different cytokines depending on the subtype, based on age, ethnicity, and other factors. And recently we published another subtype, the adult onset atopic dermatitis, those patients that all of us have that suddenly at 40, 50, 60, 70 even develop atopic dermatitis, usually with no atopic background, and at some point develop atopic dermatitis. These patients we just showed in our publication in Allergy, they have higher Th1 activation, and they also have Th2 activation, but a little bit less than the pediatric one, and also less Th17 activation. And this is why JAK inhibitors are coming handy to treat maybe all the subtypes, particularly when we cannot treat some subtypes just with Th2 inhibition. And I want to show this study that uniquely placed biomarkers as the primary endpoint. This is the JADE mechanistic study, or MOA study, that we just sent now to publication, and it was presented at the ADV. So not a large study, but when you do biomarker studies, you do not need large studies. And this took placebo as compared to 2 doses of abrocitinib, the 100 milligram and the 200 milligram doses. And although the study was not powered for efficacy, pay attention to the very clear-cut efficacy. And this is what I always tell companies: if you pick good sites, you don't need a lot of sites, but look at the clear-cut data here. Look at the placebo that is really 0, and the hard differentiation between the doses and the high efficacy here. And I told you the biomarkers were the primary endpoint, so we see now a very nice dose response and significance of biomarkers. What biomarkers we picked here? So you have MMP12, keratin 16, you have CCL18 and the S100s. We know that not only Th2 are good biomarkers for atopic dermatitis, although some Th2 biomarkers should be there. Now, this is another example of how important are biomarkers in a small study. So this is a study that was conducted by Innovaderm, by Robert Bissonnette, with a novel drug that I'm sure you'll hear also much more about it because it's now in phase 2. This is a CCR4 antagonist. CCR4 is also on activated Th2 cells, not only, but particularly on activated Th2 cells. And this was a phase 1b study of only 4 weeks. And it involved 30 patients, 20 on drug, only 10 on placebo. And as you see the clinical data, and it was not powered for showing clinical efficacy, but pay attention that the clinical data also trends in the right direction. But look at the biomarkers with very small numbers, hard significance when you look at the improvement in the atopic dermatitis transcriptome. And it's only at day 28. Look at immune genes. They are downregulated only with drug. You like to see when it goes in different direction, immune genes, and also Th22 cells. So biomarkers are really useful in early studies. It can predict later responses as well. And you already heard about tape strips. We really are passionate and really perfected this in our lab, taking an approach from skin cancers, and we now are really doing it very well in inflammatory skin diseases. So biopsies are painful, scarring. They are needed, but sometimes we can avoid them. They are prone to infection, and often not feasible for longitudinal studies, and definitely in pediatric populations. And this is one of the studies we've done with Amy Paller, where we showed in infants how accurately we could measure biomarkers in infants. Pay attention that all the suspects that you expect to find based on biopsies are here: CCL17, IL-4 receptor, IL-13, to just name a few. So we knew that we are really in the right direction, and as you heard, we also found IL-34 is differentiating 100% between children with AD as compared to children without AD. This is an elegant study that Esther Del Duca presented at the AAD, and we just sent it to publication. It's a study we've done with Robert Bissonnette, in which we compare tape strips to biopsies. And the good news, tape strips really capture the disease. You see IL-13, CCL17, CCL18, CCR4, OX40 is also here. There are some pluses to biopsies, like hyperplasia markers like IL-22 and S100s are better in biopsies. However, tape strips are capturing the disease profile. And can tape strips be used to evaluate biomarkers of therapeutic response in atopic dermatitis? And we've done a study with 26 patients before and after Dupilumab in real life, but it was around 16 weeks. And the answer is yes. You see a significant reduction of markers that we expect to find in biopsies such as CCL13, CCL18, CCL17. You find OX40 here. This is TNF-RSF4. OX40 ligand is here, TNF-SF4. And also filaggrin and periplakin are going up as we expect. And when we, even though they were not done at the same time, when we compared the tape strip data to our biopsy historic data with Dupilumab, you clearly see that they are in the same direction. Here I'm showing you only Th2 biomarkers, but you need to believe me that that's the same for the other biomarkers as well. And I always say a biomarker is not a biomarker unless it correlates with the severity or changes in the severity, and this is what we found here. We found that the biomarkers were highly correlated with the severity changes in the study. And we've done the same thing utilizing only 2 tapes using Olink proteomics. And also you see high significance for different Th2 biomarkers and beyond. So I think it's a really good approach for clinical trials and longitudinal studies as well. So with that, thank you so much. And this was a lot of data. Many people worked on it. I'm presenting it, but people like Helen and many others did the work, so thank you. And Caroline, you want to come? So I want to thank you for participating in this symposium and for attending this session, for this amazing attendance. And thank you for supporting the IEC from the very beginning. Thank you.
So I think we have a few minutes for questions, if there's any questions from the audience for any of the speakers today. So I have a quick question. That I may wait till we have a little bit of quiet to ask. So I was curious, Helen, in the work that you have done, when you see that you can predict so accurately atopic dermatitis in the future, what do you think about early interventions? What would you do with your patients in that case, that you do know that they're going to have atopic dermatitis? That's true.
Sorry, just want to make sure I understand the question. So the question was, given that we have markers that have shown some predictive value for development in the future of atopic dermatitis, like what interventions would be potentially useful, correct? Yeah, so again, I think this is an area where we are getting more and more information with time, and the fact that, for example, like these Th2, let's just say Th2, but there's different pathways as well. But let's say like taking Th2 markers, for example, I think that, for example, in the pediatric population, in infants, they, for example, if we were to detect Th2 markers such as CCL17, the ones that have been really shown to correlate with disease severity or have a high risk of developing AD in the future, potentially in the future in a clinical setting, we can, use tape strips, for instance, or take blood from these infants, these minimally invasive methods, and by detecting these elevated levels, maybe some of these interventions that have been shown to have variable evidence, such as emollient use or even preemptive treatments of some sort, could be options to consider as we continue to develop like more accurate predictive markers.
Thank you for taking a stab at that question, which is a bit of a loaded gun, isn't it?
Yeah.
I actually have my next question. Well, unless there's any more from the audience, I welcome you to come and stand and ask us questions. So for myself, one of the questions I have is with respect to the biomarkers, Dr. Guttman. I was wondering if you could comment on the role of cyclosporin, one of the older medications, on reducing biomarkers and its comparative effect relative to some of these newer targeted therapies.
So thank you so much. Excellent question. We wanted actually to study that. So a few years back, we've done a biomarker study with cyclosporin, and as expected, it does reduce all the pathways. I think in 2019 or 20, Jacob Glickman, an MD PhD that is also our first year resident, and is also a bioinformatician, he did a meta-analysis in which he compared different drugs and their effectiveness molecularly in atopic dermatitis. And we were surprised to see that actually cyclosporin was not better than Dupilumab in reducing Th2, for example. But for sure in Th1, it was better than Dupilumab. But it really reduced all the immune axis. And I think going forward, we need to be savvy, inhibit specifically, but maybe target different patient population to really maximize the responses of patients.
Thank you. And maybe to wrap it up, I have a question again for Helen about IL-34, since it is not a cytokine that we hear about very often, and given that it has this incredible potential to be used as a biomarker, I was wondering if you could tell us just a little bit about the cytokine and its role in health and disease.
Right, yeah, so IL-34 I think is really quite interesting. I think a lot of the markers that we discuss in AD, whether it be Th2 or other pathways, are pro-inflammatory, and we see increases in those markers in AD. IL-34 and IL-37 are negative regulators, so they kind of have more anti-inflammatory properties, and they are actually downregulated in AD. So part of the pathomechanism of AD seems to be not only the upregulation of these specific pro-inflammatory cytokines, but I think it's also potentially worth exploring and targeting decreases in these negative regulators or anti-inflammatory markers as well.
To go after what's missing, yes. Thank you so much. Well, I think I could probably keep this going for some time. I also have questions for Dr. Yosipovitch, who I think is back at the rest of the sessions as well. Without any other questions from the audience, I think we have a really exciting meeting coming up, and I'd like to thank you all for your attendance here today and for being here with us and for your attendance. Thank you very much. And thank you to the speakers, and in particular to Dr. Robert Bissonnette and to Dr. Guttman for their hard work, which really goes on behind the scenes more than you could imagine in order to organize sessions like these and to be bringing us all together at these international conferences. So thank you so much.